Hello students, so we're going to go over one more topic in section 2.5 on measures of position. And this last topic is called the standard score. And it says that when you know the mean and standard deviation of a data set, you can measure the position of an entry in the data with what's called a standard score or z-score. Okay, so standard score and z-score both mean the same thing. So throughout the video, I'm going to refer to a standard score as a z-score. Okay, and it gives you the definition of what a z-score is and the formula for calculating the z-score. So before we look at an example from the homework, okay, let's talk about what a z-score is and how to interpret a z-score. Okay, so the last measure of position is called a z-score. Okay, the z-score of a data value tells you how many standard deviations a data value is from the mean. And then the formula for calculating the z-score of a data value is given on page 107. Okay, so when you calculate a z-score, okay, the z-score will either be negative, positive, or equal to 0. Okay, depending on. All right, so a data value with a negative z-score is going to be less than the mean. Okay, likewise, a data value with a positive z-score is going to be greater than the mean. Okay, and then a data value with a z-score that's equal to 0 is equal to the mean. All right, so z-scores that are less than -2 or greater than +2 are considered unusual. So this is the definition given in the book. Okay, a z-score less than -3 or greater than +3 is considered very unusual. Okay, you can verify that by reading these paragraphs at the bottom of page 107. So let's go ahead and take a look at an example from the homework. So the last two questions in the homework for section 2.5, questions 9 and 10, have to deal with z-scores. Okay, so I'm going to go ahead and skip question 9 and do question 10. Okay, and the problem says that the table shows population statistics for the ages of Best Actor and Best Supporting Actor winners at an awards ceremony. The distributions over the ages are approximately bell-shaped, and the problem is asking us to compare the z-scores for the actors in the following situation. Okay, so what this problem is showing you is it's showing you the mean age, okay, and the standard deviation of the ages for Best Actor, for winners who won Best Actor. Okay, likewise, you've got the same information for Best Supporting Actors. You got the mean age for Best Supporting Actor along with the standard deviation of those ages. Okay, it says, so in a particular year, the Best Actor was 60 years old, and then the Best Supporting Actor is 52 years old. So we're supposed to use this information to determine the z-scores of each. Okay, so we're going to apply this formula when calculating the z-scores. So the data value x minus the mean divided by the standard deviation. Okay, so we need to calculate the z-score for the person who won Best Actor. Okay, and that person was 60 years old at the time. Okay, so according to the formula, right, we're going to take the number 60, okay, subtract the mean from it, and then divide by the standard deviation. Okay, so let's actually write this out. So the z-score is equal to 60 minus the mean of 43, and then divided by the standard deviation of 7.5. Okay, so we're going to put this in our calculators. Okay, so what you have to do first is you have to do the subtraction. So 60 minus 43. Okay, so we get a difference of 17, and we're going to divide that difference by 7.5. Okay, so it's not going to be a nice round number. in most cases. So we need to round our z-scores to 2 decimal places. So usually z-scores are rounded to the nearest hundredth. So it's 2.26, but the 6 is repeating, so to the nearest hundredth, this would be 2.27. Okay, so the z-score for the best actor's age, okay, at the time that that actor won the award, is 2.27. So meaning that the age of that best actor, right, it was 2.27 standard deviations above the mean. Okay, and it's above the mean because obviously, right, 60 is greater than the mean of 43. Right, so in the problem it said that the mean age of all best actors was 43. Okay, obviously 60 is greater than 43, so the z-score for the best actor is going to be positive. Okay, in this case it's positive 2.27. Okay, then we need the z-score for the best supporting actor. Okay, so these are the summary statistics for the best supporting actor. So the best supporting actor, in this case, was 52. So we're going to do 52 minus 55. Okay, and divide that by the standard deviation of 15. Okay, so putting that into our calculators, 52 minus 55, and then divide that by 15. Okay, so there's no need to round this one, right? It's just negative 0.2, so the exact answer is negative 0.2, so we're not going to round that. Okay, so that's the z-score for the person who won Best Supporting Actor, so their age has a z-score of negative 0.2. Right, and you can see that the age of the Best Supporting Actor, 52, was slightly less than the mean of 55. Right, so the z-score is negative. Okay, in particular, the z-score is negative 0.2. Right, so for this particular Best Supporting Actor, right, their age was 0.2 standard deviations below the mean. All right, so let's input our answers. So 2.27 and negative 0.2. Okay, so now we're asked to interpret these z-scores, okay, by filling in these blanks. So the best actor was blank, the mean, which blank, unusual. Okay, so let's see what the answer choices are. So the best actor was, okay, we look at the z-score, right, which is 2.27. So remember, a z-score tells you how many standard deviations that data value is above or below the mean. Okay, so in this case, the z-score is positive, so it was more than 2 standard deviations above, right? So it's 2.27, so more than 2 standard deviations above the mean. Okay, so which, according to the book, is unusual. So if a z-score is greater than positive 2 or less than negative 2, it's unusual. All right, so the best supporting actor was, so it was not quite 1 standard deviation away. Actually, it's less than 1 standard deviation away. So, and remember, it's negative, right? So it was less than 1 standard deviation below the mean. Okay. And that's because the age for the best supporting actor was below the mean. Okay, so it was less than 1 standard deviation below, right? Because the z-score is less than 1. Okay, which is not unusual. Okay, and that completes question 10. Okay, so question 9 is similar. It's going to ask you to compute the z-score using the formula, interpret the results, and then determine whether that data value was unusual based on the z-score. Okay, so you can do that on your own. Now, I do want to caution you that when you compute a z-score on your calculator, right, it's possible to get an incorrect answer. Okay, so let's say we were computing the z-score for the age of the best actor, okay, who was 60 years old at the time. Okay, so let's say you did it this way. You did 60 minus 43, and then you divide by the standard deviation of 7.5. Right, that's how you calculate it. Okay, but if you input it into the calculator incorrectly, it's going to give you an incorrect result. Okay, so when you do 60 minus 43 divided by 7.5, okay, what your calculator thinks you're doing is thinks you're dividing first, and then subtracting. So what it does is it does 43 divided by 7.5, and then it does the subtraction, 60 minus whatever that is. So 43 divided by 7.5 is some number. Right, 60 minus that number gives you 54.2666, which is incorrect. Because remember, the correct z-score is 2.27. Okay, so what you have to do first is you have to do the subtraction first. Okay, so you're going to put in 60 minus 43, get equal to. Okay, we get 17. So you calculate the difference between the data value and the mean first, and then you divide by the standard deviation. Right? If you subtract, okay, then divide, okay, without calculating the difference, you're going to get an incorrect result. Okay, likewise, if you do 52 minus 55 divided by 15, again, that's not equal to the z-score that we got, which is negative 0.2. Okay, so just be mindful that you do the subtraction first. Okay, hit equal to, or enter. Okay, and then divide by the standard deviation to get the correct z-score.